Sometimes Yo-Yo Games adds features to GameMaker which nobody really expected them to, but are actually really cool. Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games. Let's talk about GPU texture compression. So this came out about maybe a month ago, and as far as I know, there was no warning about this coming, it just showed up one day. GPU texture compression is basically what it sounds like. It is a way of making textures in your game take up less space. This differs from what GameMaker will already do in exporting the textures in your game when you build your game as a PNG or as one of some other file formats. By default, GameMaker will uncompress all the textures in your game when it loads them into memory, so that one pixel will take up 4 bytes, 8 bits for a red, green, blue, and alpha channel. You know how it goes. Whereas GPU texture compression will allow the textures to stay compressed in memory when your game is running, and your GPU will be able to access them while they're compressed. And this has a number of benefits. The obvious one is that your game will need less VRAM to run, and there's a few downstream consequences of that, such as you will be able to fit more textures into VRAM at once so that you won't have to swap texture pages quite as often, at least potentially. And since textures will be compressed in memory, the same way that your CPU has a memory cache for frequently accessed data, so does your GPU. And since the texture data is compressed, your GPU will basically be able to fit more pixels into its memory cache at once, and this can speed up the process of texture fetching by some amount. Now, all of that sounds great, but there is one potentially big downside to all this. At least it'll be a downside for some games more than others. And that is that GPU texture compression is lossy, which means that some visual information will be discarded and you can potentially see a loss in visual quality when you do this. And you can think of this very similar to the JPEG file format. JPEG, as I'm sure you're aware, is a good file format if you want to store things like photographs of the natural world. Slightly less good if you want to store images such as, for example, pixel art. GPU texture compression is a very similar deal. I will be doing some side-by-side comparisons of different types of images later in the video. So, if you want to use this in your game, I will have a link to this GitHub repository down in the description of the video. This is provided as an extension to the engine rather than something that's built in automatically. So if you want to use GPU texture compression in GameMaker, come to this page. Hopefully at some point in the near-ish future, Yo-Yo Games will provide an official release on this GitHub repository, but unfortunately we haven't done that yet. I don't know if they're going to do that soon. I hope they do. I don't know if they're considering it like still to work in progress or something like that. But anyway, this is okay. We can get the extension files out of the repository itself. By the way, the tools that they use to do this, they do have their own licenses based on the GPU compression algorithm that you go with. You can find them here in the README of the GitHub. They're both, I believe, they're both open source licenses. This one here, ASTC, uses the Apache 2 license, and I think the other one, I think this one uses something along the lines of an MIT license. They're pretty permissive licenses, but just maybe something to keep in mind. The documentation I found on this GitHub wiki here is also fairly good, and you can go and read through that if you would rather read something than listen to me. So you can download the repository if you'd like. You can either download a zip or you can clone it with Git, whichever you prefer. I'm not going to do that because I've already gone ahead and done that. If you open up the sample project, you will find that it is basically GameMaker's Windy Woods sample project, which some of you might be familiar with. All right, that took a minute to start because this is the first run of the day. But anyway, it's a basic platformer example project, and it's something I'm not very good at, so I'm gonna try not to play that too much. Anyway. So firstly, if at the time of your watching this there is not a release provided on the GitHub repository and you need to go into the sample project to get the extension yourself, we can do that by going to Tools and Create Local Package to basically export the extension from the sample project. I'm just going to go and fill in... Really? The tab button is not working to cycle through? Okay, fine, GameMaker. I'm just going to call that compression. Anyway, go and add the texture encode extension to your local package, and you can click OK and save that wherever you feel like saving that. And that will save a little GameMaker extension file, which is basically a a zip file in a trench coat. Anyway, once you have this compression.yympс file, you can just go drag that into the IDE of whatever project you'd like to add it to. This will also be true if you downloaded it from GitHub. If there was a release on the release page, you just drag that into your GameMaker IDE. You add the extension files, click import. I'm not going to do that now because it already exists in this project. And now you're ready to go. So the way that this works is that there are, if you go into Tools once again and the Texture Groups page to open up the texture groups. If you don't know how GameMaker manages texture groups and texture pages, I did make a video on that a while ago. You might be interested in going and having a look at it. Knowing how this stuff works can be fairly useful. There's a couple of options in here that are relevant to us. So one of them is going to be the texture group format. By default, I think it will be BZ2QOI, which is the compression algorithm that GameMaker uses when it builds your game. And then, like I said, when the player runs the game, it'll be uncompressed into memory. You're going to want to set your texture group format to custom, and you're going to want to insert something into the custom options field down at the bottom here. And what exactly you put in here will depend on what platforms you're working with. So there are overall 3 different texture compression algorithms that you might use in your GameMaker game. One of them is ASTC, and that will work for basically mobile devices, iOS, Android mobile devices, and Nintendo Switch, which is basically a mobile device cosplaying as a home console. You have BCN, which will work on basically everything else besides Linux. It'll work on Windows, Apple computers, Xbox, PlayStation 4, PlayStation 5. And the third option is GNF, which will only work on PlayStation 4, PlayStation 5. I am going to be using BCN for this video because I am doing this video on Windows here. Unfortunately, there is a bit of a conspicuous absence of GPU texture compression that will work on Linux. I don't know if there are GPU texture compression algorithms that will work on Linux that GameMaker might add to this in the future, or if that's just kind of out of the question for now. But anyway, we'll work with what we have. So what exactly you type into the custom options field here for each texture group is basically command line arguments to run, to invoke a third-party tool that will run the compression algorithms on an image, that image being, in this case, the texture page. There's a handful of different settings that you can apply to each of these compression algorithms that will basically be a quality setting, like the JPEG quality setting that you might see in Photoshop or something like that. Although I have to say, in my experience, I haven't seen a great deal of difference between low quality and high quality when it comes to these texture compression algorithms, at least with the images that I've tested it with so far. And also, there are a number of different configs in this sample project with different compression algorithms and different compression settings, which you might want to play around with just to see what the differences are. Like I said, I believe GameMaker's default is BZ2QOI, so that's just the image format, uncompressed at runtime, no GPU texture compression. We've also got a config with an ASTC compression setting, a BCN compression setting, or 2 of them actually, GNF if you're interested in working with the PlayStation. First, I'm going to, I think, run this with BZ2QOI, which is just going to be the default, and I'm going to treat this as a bit of a control. Let's see, I'm going to do a couple of things here, which is that when the Windy Woods demo starts, let's see, let me minimize that. First thing I'm going to do is take a alt print screen of this game window, and I'm going to take a screenshot of that window and just paste it into Photoshop, and I will be doing a comparison with different compression settings later on. If you hit the Alt key in this demo, it will basically draw a sample from every texture page, which will load all the textures into memory at once. Windows, unfortunately, does not have an easy way of telling exactly how much VRAM any given process is using, but there is a little utility with the most PC gamer name of all time called Tech Power Up GPU Z, which will provide some metrics on what's going on your GPU. If you go to the Sensors tab, we can see the amount of memory used, 1548 megabytes in my case, out of about half of 3 gigabytes, and Let's see, let me close that. When I close the game, it will drop down to about 1358. So it's about, this game will use about 200 megabytes of VRAM on its own. If I were to run this with BCN-U2 quality setting, I can do a little comparison. Let's see, if I hit the Alt key to load everything into memory at once, we are going with about 1452 megabytes of VRAM, so that's about 100 megabytes. That's about half of what we're using by default. So there's some significant savings when you do this. And if I were to Alt print screen once again, to take a screenshot, let me paste that into Photoshop here. I will name these. If I slap the difference blend mode on the top one of these images, this will basically do an image diff. And if you zoom in, you will be able to see the brighter pixels are the pixels that are more different between the top and the bottom image layer here. And you can see that it's these two images are pretty similar. So there is a little bit of if you look closely, you can see a little bit of image compression artifacts around things such as the buttons on the UI, or maybe around the edge of the hamster character. I think that's a hamster. I'm not entirely sure what that is, but they're very slight. For the most part, you probably wouldn't notice by eye that something is off about this unless you really zoomed in on it. Really, the buttons on the UI are the only really significantly bright pixels in this image diff. Everything else, it's mostly outlines where the compression artifacts can be found, but even those are pretty slight. All right, and then of course, if you were to actually play this, especially when it's in motion, it's unlikely that you would really notice anything is amiss here, unless unless you were really looking. All right, I'm gonna stop before I embarrass myself. I'm not going to go over all of the potential settings you can feed into the BCN command for like quality and whatnot, but generally speaking, BCN-U0 is going to have a higher compression ratio but lower quality when it comes to the image compression. BCN-U4 is going to be the highest quality, and BCN-1, 2, and 3 will be in the middle. Although, if we're being honest, I did a bunch of side-by-sides earlier before I started recording this, and I really couldn't see that much of a difference between U0 and U4. So I don't really think it's worth trying to show off them all in this video. You can play around with the different compression levels and see what you think. Let's see, I think that's all I wanted to do in this sample project. There's also the matter of maybe a less flattering example of GPU texture compression, an example where this won't look quite as good. So let me open up this depth equals -y sample project. So this is a pixel art game example. We've got a pixel art character, some pixel art flowers, a lot of pixel art in this game to go around, and this is not going to behave nearly as well when it comes to GPU texture compression. So let me actually start that over and take a print screen right when the game starts. If I go over to Photoshop, let me open a new page, paste that in. By the way, let's also have a look at VRAM savings. That's not GPU-Z. Where's GPU-Z? So right now we're sitting at about 14 megabytes of VRAM used. Let's call it maybe 50, 60 megabytes of VRAM used for this this project. If I close that, all right, maybe 50. If I close that, it'll go down to 1372. If I were to go and drag in the GPU texture compression extension, we can import the extension. We can close the project tool. That's going to load the texture and code extension into this project. Let's go back to the texture group tool. We can set the format to custom. We can set custom options to have out BCN-U2. We can run the game once more, take a print screen, paste that. No. Paste that into Photoshop, and that's why when I did that, did all of the like the positions of flowers changed. Hang on a minute. It was not doing that when I was testing this out. We should be using the same random seed every time. I would like it if we use the same random seed every time. Okay, I don't know why GameMaker wasn't using the same RNG seed between runs of the game, because it's usually supposed to do that, but anyway. So, visually, just by looking at these two images, you definitely can tell that something is amiss. It might be a little bit hard to tell exactly what's wrong at first glance, but something definitely looks off about these colors. If you zoom in, we can see that while in the original image, each of these pixel art flowers are really use a very simple color palette. There's just a couple different colors for the petals, a couple different colors for the leaves. The version that's running with texture compression, we can see that not all the colors are true to the original. Like I said, we are discarding some visual information when we do this. In some circumstances, that does include alpha channel values. Like, this would be bad enough for pixel art if it didn't also mess with the alpha of certain pixels in its compression, but we're, like, to add insult to injury, some of the pixels you can see through some amount. They have a, like, partial transparency value, which is a little weird. And if I were to zoom out to a macro level and toss the difference blend mode on it, we can see that there are quite a lot of pixels in this image that are different between the compressed and the uncompressed image. Right, so this is a lot noisier. This pixel art game is a lot noisier than the sample project with the HD art. It doesn't help that pixel art games like this sample project are also generally going to be like blown up so that you can see the individual crunchy pixels, and that's just only going to serve to exaggerate the compression artifacts. So that is an example of a game which will not benefit much from GPU texture compression. Oh, by the way, I was in the mood for comparing VRAM usage. So this really isn't going to cut down the amount of VRAM that this sample project uses by a lot at all. The graphics in this game are tiny. They don't take up a lot of space to begin with, just probably a couple tens of kilobytes, maybe 100 kilobytes or so. And how do I keep opening Task Manager? If I were to run this with texture compression enabled and look back at GPU-Z, we are using about the same amount of VRAM as we were using before I started messing with this. So we really didn't reap any benefits of this at all. All we really got out of this are worse looking pixel graphics. So if you're making a pixel art game, GPU texture compression is not something that you're really going to be getting a lot of use out of. Games that would benefit a lot from this are things like the Windy Woods demo with large bits of HD art. If you're making a visual novel or something with large HD wallpapers and large HD character art, you could benefit a lot from this potentially, because visual novels tend to have a lot of graphical resources. If you're making this isn't something that most people are doing in GameMaker, but if you're making a 3D game with large 2K or 4K like PBR textures, that would benefit a lot more from GPU texture compression than a pixel art game would. In fact, if you've ever like gone into like a AAA game and like extracted the like texture assets from it, a lot of times you will see image files in like large AAA games stored as DDS. Those are Microsoft Direct Draw Surface image files, and that basically is just a compressed texture with what we're looking at. And in case anyone's wondering, different compression settings do have different compression ratios. But generally speaking, you can expect about maybe a 4:1 compression ratio for these things. So if you have a 4K texture, 4K is going to be 4096 by 4096 times 4 bytes per pixel is about 64 megabytes, is how much a 4K texture will take up uncompressed. If you have a 4:1 compression ratio on that, you can cut that down to 16 megabytes for a 4K texture. And you can see how for a game with large HD texture assets, that would be definitely something that you want to take advantage of. So, I'm going to end this off here. My name is Michael. I like Wizards and Dragons and making games. If you want the code for this, I will not be posting my own sample project for this because I didn't really do anything interesting, but I will have a link to the GPU texture compression GitHub repository down in the description of the video. And that will, of course, contain not only the extension itself, but also the Windy Wood sample project, so you can play around with that. I like to post videos on the weird stuff you can do in GameMaker, so if any weird graphical stuff or any weird 3D stuff is what you're into, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. You should all go check out the Steam page for Wizarducks, which can be found down in the description of the video as well. Will not be using GPU texture compression in that game, by the way. I really hope this video came out okay, because this is like the 4th time I've tried recording this, and I haven't come out with something that I really like yet, so hopefully this one will get the job done. I hope you all found that useful, and I will see you all later. Special thanks to Zenjamin, TheTroV, Squarecrow, Mentore, GameMaker, Edward Holt, DJ Gibbles, and Black Alien for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.